Now we're going to talk about model building. A few things to take into consideration in regards to data. First, the target variable is a continuous variable. School enrollment rate can be anywhere from 0 to 100 for each country. For that reason, logistics regression was ruled out. The data is linear, so we're going to utilize three different models: linear regression, regression, and neural networks. And the independent variables are continuous, and for that reason we broke them up into categories in the style of low, medium, high. I'll talk about that in some more detail in a little bit. Exploration issues. No values in the data set were changed to blank, so that we can change the storage type to continuous during the model building. And also the no values in the dependent variable were causing errors in R, and the values were changed to NA to perform descriptive statistics. Alright, this is the exploratory analysis. What you see here is the simple descriptive statistics. On top we have our dependent variable, which is the adjusted enrollment primary rate. We see such things as the mean, the media, maximum value, the minimum value, variance and standard deviation, as well as a few other items. Below that we see for the independent variables, and you see the same data for those variables. Here we see a little bit more detailed descriptive statistics show for one of the variables. Expenditures on primary education as a percentage of total government expenditure. Alright, on the top left we have a bell curve representing the data, and then we also have some more statistics in the bottom left, as well as a few more visualizations of the data. We also enter the data into R to verify the descriptive statistics, and as you can see here, each variable has a minimum value, a max value, mean, median, a little bit more information here. As part of the exploratory analysis, like we said earlier, we divided the independent variables into different levels. Over here we have GDP per population, broken into six variables, starting from poor and going to super high. And as you can see, as GDP per population grows, so does the enrollment in primary school. Then we then put the data into Power Pivot to do an analysis on the adjusted enrollment rate for primary education. I'm going to show here. This is what we got into Power Pivot, and as you can see, some of the information is inversely related to enrollment rates. Things such as the repeaters with primary grades and cumulative dropout rates, we expect those items to be inversely related. One item that surprised us was the expenditure on primary education as a percentage of government expenditure on education that is inversely related as well to enrollment rate, and that was a bit surprising. For building the models, we utilized IBM SPSS Modeler. The first model was linear regression. That model summary gave us 89.6% accuracy, and the most important factor was the repeaters of primary, all grades. The second model was neural networks, and that model summary gave us 98.3% accuracy, and the most important predictor was expenditure on primary education as percentage of government expenditure on education. And the third model is regression. The most important predictor was also the expenditure on primary education as percentage of government expenditure on education. And that regression model gave us this equation, and as you can see, each variable has its own coefficient. In this case right here that I'm highlighting, it's a negative coefficient to show that the dropout rate is negatively related to the enrollment rate.